Right. In quality of service, we really spend a lot of time to configure the quality of service. How? We analyze the traffic for a couple of days. Depending on the environment, you take a couple of days or a couple of weeks to analyze the traffic and see which needs some extra care. I told you in the previous class we have various types of traffic. Now, among these types of traffics that is there in your network, which traffic or what are all traffics need more attention, more care, more priority? So those things we take time, really a lot of time to analyze. Time to time we take logs, and then we use some tools to analyze the traffic and see the applications that really need an additional care. Only then the applications will successfully do the job that the application is supposed to do. For example, some applications are time sensitive. If the reply is not coming on time, then application will reset and you need to do it again from the beginning. So to avoid that reset, what you need to do is you need to prioritize so that the response comes on time or before time, not late, not time out. So identifying such traffic is not just 1 hour job. Some traffics at 9 o'clock you may not experience problem, but when it is a peak hour, you will see some applications traffic getting dropped or getting delayed. At 9 o'clock it was nice, but at 11 o'clock the same application which was happy at 9 o'clock is no more happy at 12 o'clock. The reason is the amount of traffic has increased gradually from 9. People started logging in, various applications, various type of traffic initiated from various users. So the change in the volume of traffic that is being routed has created some impact. So these things you will get only when you analyze. Sometime on Monday you will find the problem, not on Wednesday or Thursday or Friday. Again, it depends on the environment. So now, after doing that analysis of data, we come to a conclusion with some set of traffics and the level of prioritization to give to avoid drop or delay for those traffic during the peak hours. For that, we classify them. We write class map. You remember I was telling you MPF, Modular Policy Framework, or policy-based routing, PBR. So using that, we classify and take an action in the policy map, and at last we apply it globally or interface level. Wait, I want to tell you this point. You are mixed with this particular thing which I explained to you now, and the other one is this. These two things got mixed. What is the other one? The other one that I said is, even though you spend hours together, weeks together, and configure QoS, that will never be effective if there is no congestion. So you mixed these two things. Congestion, only if there is congestion, the quality of service that we apply will be effective. This is one part. Another part is configuring quality of service needs MPF or policy-based routing, PBR. Okay, so two things you mixed. My question was, what? What was my question to you? Oh yeah, but the question was how. I think it was how quality of service is done, something like that. So your answer was according to the policy, uh, the action will be only when the policy is met, the action will be taken. If the policy is not met, not taken. So I got confused. Now, are you talking about the QoS, which will be effective only during the congestion? Congestion is also a constraint now. If there is no congestion, there is no QoS, isn't it? When there is no congestion, there is no QoS. The QoS that we are okay. So I thought the other way also. You said only when there is a match, and I was asking what match, the policy match. Then it immediately made me to think about class map and policy map, that MPF thing. Okay, fine. So how do we configure quality of service by MPF? What is the other name of MPF? PBF. Fine. Modular Policy Framework or policy-based routing. Now, we also ended our class by talking about three types of quality of service. One, integrated service. INSER, integrated service. The other one, DIFSER. And then FIFO. You see, integrated service is not seen everywhere. Very rarely you will see INSER. Not every ISP will be happy to provide you INSER. Very few. That too when the customer pays a big amount of money. Why? Because INSER is end-to-end reservation. End-to-end. End-to-end. So in between, you may have many routers. Now, what INSER will do is, when a particular traffic comes, which matches the INSER policy, this head end, I would like to call this as head end, and this one as tail end. This head end will send a special message to the tail end, and tail end will send will send a reserve message. Will tell every router in the path from tail end to the head end to reserve an amount of bandwidth that you configure for the traffic to come. During the time, no others can use that bandwidth. You see, when packet has not even started coming out of the router, it's still not started, but already the reservation is done on all the routers. The reservation is done everywhere. and that reserved bandwidth no others can use. So if any traffic wants that bandwidth, which wants to go this way, wants that bandwidth but will not be given. Why? It has been blocked by INSERV. So till that session gets over, that reservation will be there between the head end and the tail end. Every router in the path have to keep holding that bandwidth until this traffic pass through. Which is not feasible for service providers. Why? Service providers need to serve hundreds of customers. Just for one customer, if they do this, if they do this for every customer, then they won't have enough bandwidth. A lot of customers will start complaining because they are not provided service. There will be a delay in service. So INSERV is not widely seen quality of service. INSERV is not hop by hop. INSERV is end to end. Hop by hop is diffserv. Hop by hop is best. Why? Every hop determines how to treat the packet. So when the packet arrives to the second router, then only the router will determine how to handle. It is not before the first router sends. Second router will not do any reservation if it is INSERV. You see, in INSERV, no reservation. Every router, as they receive the packet, after they receive the packet, they decide what sort of treatment, what sort of priority that it will give. There is no end-to-end reservation. When the traffic is in first router, the third router is not going to have any reservation for the traffic. The traffic needs to come to the third router. And then third router will see what to do with the packet. After sending the packet out, the reservation on the third router will be cancelled so that others can use. You see, hop by hop QoS is diffserv. End-to-end quality of services INSERV. Did you understand? Hmm. 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 Correct. See, if you take an airport, then if they work in INSERV, then problem. Say, for example, from India to US, uh, a flight needs to land in two airports in between, let's say. In between, there are two transit. Now, the flight is going to start from India. Okay, in Dubai, if they do the reservation for this flight, the runway reservation, will that be a wise method? No. The flight is still not left. It is not. It is still in India. It's going to start. So why should Amsterdam and Dubai reserve the runway? It's useless because there is a flight time involved from India to Dubai. It takes at least 4 hours. Now, in that 4 hours, that reservation, the blocking of runway, can be used by some other flights. So, INSERV is not recommended. In-serve is like the flight going to start from India, but you do a reservation in Dubai, in Amsterdam, in New York, um, the runways, which is funny, which is not correct. Maybe applicable for that one flight. What is that flight named as? I don't know, some one. What one? You know it. The 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 flight what our president uses. What one? Yeah, that for that one flight also they won't do. I don't think so. They will do that reservation of runway before it starts. It's funny to think like, okay, anyway, in service not good, but still in service in use. You know where? RSVP, traffic engineering using RSVP. We do the reservation end to end. That's why that is a very costly service. That's why they charge you more if you go for RSVP traffic engineering. They charge you more because they need to block the path, the megabits that you want from end to end. For that one customer, he will be happy. What about the other customer? Problem. They won't have enough bandwidth. So InServe is not a recommended one. Example for InServe is RSVP. What we are going to see in the whole QoS class is diffserve only. Differentiated service. Every hop will determine how to deal with the packet. The level of treatment on every hop may be same, but it is given only when the packet arrives. It is not before the packet arrives. Okay. So what are the other things we discussed? There are a few more important things we discussed. Can you recall and tell me? Okay. You remember the layer 2 quality of service is called COS. COS stands for class of service, right? Class of service. And do you remember how many bits are given for class of service? 3 bits. 3 bits. Yeah? Yeah. So 6 and 7 are high priority markings, and they are not given to any of our traffic. They are only for management traffics. Which is more important, our traffic or management traffic? Yeah, which is important, telnet or OSPF? No. Sorry, what did I ask? Telnet or OSPF? Of course OSPF. OSPF is the management traffic. You are right. OSPF is the management traffic. If OSPF cannot provide route, you cannot tell that. Yeah, so what you said is right. Yeah, so management traffics are high priority. For those management traffics, that 6 and 7 are even. From 1 to 5 onwards, we have the flexibility. We can decide. Mostly 5. 5 will be given for voice. COS 5 is given for voice. See, voice is the most sensitive traffic in the internet. You know that? Voice cannot be delayed more than 300 milliseconds. Voice cannot be delayed. See, I'm speaking from here. In between you and me, thousands of kilometers are there. But still, you are able to get it very clear, it is because of the QoS. There is no delay more than 300 milliseconds between you and me. If there is more than 300 milliseconds, then you might have got some, uh, you will not be comfortable. You may ask me to restart my laptop, or you will restart your laptop. We may need to disconnect and connect. Some troubleshooting because we are not comfortable in hearing when there is delay of more than 300 milliseconds. So what do you understand from this? More than any other traffic, voice traffics are means according to the. I'm not talking about the management traffic. I'm talking about users traffic. So quality of service, the users traffics are many. In that user traffic, voice traffics are very sensitive. They need to reach before 300 millisecond delay. To any destination, it has to reach before less than 300 millisecond. If not, problem. So usually the marking 5 is given for voice. For the other traffic, it is your wish. For other traffic, you can decide. All right, voice or any other multicast traffics, UDP traffics, it is recommended to give 5. All right. Other than QoS, did we learn any other marking? We learned 2 more, no? QoS is layer 2. Can I configure? Can, yeah. Can I configure QoS on a router? Yes. Even though it's a layer 2, you can ask layer 3 router to set layer 2 QoS. Okay. What is next is we also learned IP precedence and DSCP. IP precedence and DSCP, differentiated service code point. IP precedence and QoS both are having 3 bits, so it's the same same weightage. But for DSCP, we have 6 bits. How many? Differentiated service code point has got 6 bits. In that, this will be always 0 and never be used. So don't care about it. And this 5 is what matters. In that 5 also, these 2 and this 3. This one is for drop precedence. I'll talk about that in a few minutes. Now you will not understand. So in short, what I want to say now is, what you need to know now is, DSCP out of 6 bits, it uses 5 bits. Sorry. In that 5 bit also, this will always remain 0. We'll talk about that. So what is the size of DSCP? DSCP. What is the size? You have it in the screen. 5 bit or 6 bit? Anything you can say. Yeah, out of 6 QoS bit, 5 bits are in use, right? From where you got the 32 bit? Hmm, 5 bits, okay. Now, I'm going to bring a chart to explain you this DSCP, you will understand it in a better way. How many bits the DSCP is using? 5. But I was also telling there are 6 bits, always the last bit is 0, isn't it? Do you see here 6 bits in everything, every class, every column? You see 6 bits. And the 6th bit is always. There is one thing I want to clear. Next one. Out of this 5 bit, I was putting like this. You remember? 3 and 2, isn't it? Now, tell me, what is the value of this one? Just only take this. I don't know. No. Just take only that 3 bit. That's why I put that bracket 1. You see that 1 here. And what is the value of this one? That's why AF11. Okay. I'm helping you to understand what does AF11 means. AF11 in binary, this is what it means. Now do this and see. What is the value of this one? What is the value of this one? I asked you to see this 2 separately and this 3 separately. That's why AF33. Now verify yourself this one. AF23. So you understood what is AF23 means? You know, you see, now you have a value above, you are saying that. But if I ask you without showing this table, AF32, you should be knowing this. What does AF32 means? 3, 3, and 2. And the 0, or the usual 0. So you should know to write this. AF32. All right, now do you know how to write this? Okay, with this knowledge, now let us go. DSCP. These values are called as DSCP. How many bits are there? There are 6 bits. 6 bits, which is 2 to the power of 6, which is 64, isn't it? In COS, how many probabilities were there? 7. 7 probabilities were there, isn't it? In COS and IP precedence, when you have 3 bits, okay, you're starting from 0 means it will end up in 7, no? Okay, so if you have 4 plus 2 plus 1 is what? 3 bits, 7 only, no? 7. So if you have 6 bits, you will get 64, isn't it? 64 different probabilities. That is first thing I want to tell you. DHCP has got more marking values. In COS, you got only 3 bit, so you can have only 7 different markings. In DHCP, how many markings you can have? 64. Yeah. Now we are trying to understand the meaning of it. If someone is having, not someone is having, when a router is receiving a packet with AF43 and some other packet with AF11, understand the story very well. This is the pipe. The router is receiving a packet with AF11 and AF43. There are many AF11s and AF43, and there is a congestion. And router needs to prioritize one and drop the other one. Which one it will prioritize based on, it depends on what AF it is holding. You see, AF4, see this number, first number. 4 is bigger or 1 is bigger? 4 is bigger. So definitely it will drop these packets, AF11 packets, so that AF43 will not get dropped. Did you understand that part? So what I just explained is how marking can be used to decide whom to give high priority. Right. Now, next important point. I am getting a lot of AS43, also a lot of AF41. Now there is a congestion. Which one to drop? See, try understanding. Earlier, packets were coming with this and this. This has got low priority. This has got high priority. So you dropped all AF11, isn't it? Now the situation is different. Or, or no. Earlier, I did not say 41. We have not started the conversation of 41 and 43. Hold on. Earlier, 43 and 11. This is what we were discussing. 43 or 11. Which one it will drop? 11. Now, 41 or 43. Which one it will drop? No. That is what the opposite. This is low drop probability, meaning you need to see the second number now. You see, this is drop. This is class. 42 is class 4. 11 is class 1. Class 4 is important or class 1 is important. Class 4 is important. So you drop this. Okay. Now it is the drop probability between the same class. When it comes to same class, the high drop is for the big number. 3 is bigger than 1. This is low drop. So when there is 41 and 43, which one will get dropped? 41 or 43? Now I'm going to check whether you understood this well one more time. I have AF33 and then AF23 and then AF21 packets. Now there is a congestion. Which one to drop first? Which one will get dropped first? To avoid congestion, which one will get dropped first? Exactly. Bravo. Correct. Even after 23 dropped, still there is a congestion continuing. Which one to drop? Exactly. So 33 will never get dropped because you got AF23 to drop. Congestion will be fixed even if there is congestion, even after dropping 23, will drop 21. Now with all this knowledge, we will be going to different queuing QoS methods. All right. These are all values that we are going to use in QoS. But there are different QoS methods like weighted fair queue, FQ fair queue, WFQ weighted fair queue, weighted random early detection, priority queuing, low latency queuing, class-based weighted fair queue. There are various types of queuing methods. In all those methods, we'll be using these things: COS, IP precedence, and DSCP. That is why we have learned this, right?